Fine. See, in this particular video, you are going to learn the divisibility test for divisor ending in 9. That is 9, 19, 29, 39, like that. So, I am going to more concentrate on prime numbers, right? Only for the showing the model, I am going to show you this. The sutra which I am going to use is Ekadika and as well as Vestanam. Ekadika means one more than. Right, let us check out with this. Main thing, you have to practice by using table for one or two problems. Later stages you can calculate mentally. Right, let us check out with this. For any divisor D ending in 9, the positive oscillator, there are two type of oscillator. One is positive and second one is negative. Right. So we are going to use positive oscillator for this particular problem. Right, the divisibility test for ending in 9. Right, so it is oscillator is equal to 0 plus t is defined as 0 plus t is nothing but d1 plus 1, where d1 is number obtained after deleting the unit place digit 9 from the divisor d. That you will know while using the 7 and as well as 13 divisibility rule, right? That is Ekadika. So similarly here, when you multiply any number by 9 into 1, you are going to get 9 only, that is 0, 9. So you are supposed to cancel this or delete this, the remaining number will be 0, add 1 to this, 0 plus 1 is 1, 1 is the Ekadika of 9. Similarly 19 ones are 19, if in case 7, what happens is that 7 into, so the 9, it should end with 9, 7 sevens are 49, then you leave 9, 4 is the remaining number, add 1 to it, 4 plus 1 is 5, 5 is the Ekadika of 7. Similarly, the same concept I am going to use here, 19, for 19, 19 ones are 19, so leave 9, the remaining number is 1, add 1 to it, 1 plus 1 is equal to 2, 2 is the Ekadika of 19. Similarly 3 is the Ekadika of 29. Say for example, if you want for 59, 59 ones are 59, leave 9, 5, 5 add 1 to it, 5 plus 1 is equal to 6, 6 is the Ekadika of 59. See what is the beauty of this, no? So you are not going to divide by the actual divisor, that is 59, you are going to divide the divisor by 6 to find whether the given number is divisible by 59 or not. Right. Once you understand this, let us go with this. The structure, the table structure will be like this. This is going to be what? A number I mentioned here, that is dividend. That is dividend here. Right. And as well as the next row should be remainder, that is r into 10 after division. When you divide the given dividend by the divisor, which may be 9, 19 or any number, so then you are going to get some remainder, then that you are supposed to place in this particular row. Then digit of oscillation quotient, that is whatever the quotient you are going to get here, that should be placed here, and then oscillation result, this and as well as this you need to add and place it here, that is oscillation quotient. So let me explain with an example so that you can clearly understand the working aspect. Right, let us check out with this. So they gave that is 2312 is divisible by 9 or not. You can directly check by using the rule, which already you know, the sum of the digits of a number must be a multiple of 9. So then the number is divisible by 9. Only for working model I am going to show you. So this method you can adopt for any number which ends with 9, 19, 29, say, or otherwise 39, 49, 59, right, 69, 79. If it is only prime number, you can go with the 19, 29, right, 59, 79, right, 89, something like that, say 119. You can go with that. Let us check out this. So 2312 is the number which I am supposed to find whether this number is divisible by 9 or not. Right. Here only up to last digit you need to take, before last digit up to here. This is going to be the remainder portion and this is going to be the quotient portion, right? And this is going to be dividend. The next one is r into 10. R means what? Remainder. Then is oscillation, the digits of oscillation quotient. Then oscillation result, right? Then this is going to be oscillation quotient and as well as remainder you are going to get here. Fine, in this particular row. Let us start dividing by 9. But you are not supposed to divide by 9, you are supposed to divide by ekadika of 9. Ekadika of 9 is what? 1. You are going to divide this number by 1. Right. So now, 2 I will take here. When you divide 2 divided by 1, what you are going to get? The quotient? Quotient is 2. Right. Remainder is 0. Right. 2 I will write here. Right. What is the remainder? Remainder we got 0. 0 into 10. Remainder is 0 and into 10, that is 0. Right. Digits of oscillation quotient, that this you need to place it here. 3 plus 2 is 5. 5 is the oscillation result. Now you are not supposed to divide 3, you are supposed to divide 5. Right. 5 divided by 1, that is 5 only, and 0 remainder, right, that is 0. This 5 I will place, that is digits of oscillation quotient. 5 plus 1 is 6. Now I need to divide 6 by 1, that is 6 only I will get. 0, right, here 6. So 6 plus 2, 8. You can stop here. Now this number I am going to compare with the actual divisor. Actual divisor is 9, which is less than 9. This 8 is less than 9. So that is going to be the remainder. If it is more than, then we can divide that particular number by 9 and we can get the quotient and as well as the remainder. Right, here we can easily conclude that this number is not divisible, that is 2312 is not divisible by 9. Why? Because here it is not a multiple of 9, or otherwise we are not got any 0 also. If you got 0 or otherwise 9 or multiple of 9, then this number is divisible by 9, or otherwise it is not divisible by 9. Right. So here what happens here? The quotient, actual quotient is 256 and remainder is 8. The conclusion what I can do, this test whether 2312 is divisible by 9 or not. No, it is not divisible by 9. Find the quotient. Quotient is 256 and the remainder is 8. You can apply Navashesha to check this also. Right. Let us check one more example, that is by 9 only. Right. Let us go with this. 19654, whether this is divisible by 9 or not. So what we need to do, we are supposed to divide by 1. 1 divided by 1, we are going to get 1 only and 0 remainder. This 1 I will place it here. 9 plus 1, 10. So I need to divide 10 by 1. That is, we will get only 10 only. That is, but only one digit should be there to find the quotient. So that's what 0 and 1 I will keep it like this. 1 will be considered as a carry. Okay. So the next is, so what is the remainder you will get? 0. This is r into 10. This is dividend. What is this? This is digits of oscillation quotient. And what is this? This is oscillation result. Right. Now let us check out this. 10. So 10, when you divide 10 by 1, you are going to get 10 as the quotient and 0 as the remainder, and digits of oscillation quotient is 10. The new, that is oscillation result, will be 16. So when you divide 16 by 1, you are going to get 6, 1. Right. Now what happens? 16 divided by 1, again 0 and 16. 16 plus 5 is 21. 21. Now I will divide 21 by 1, that is I will get 21 only the quotient and the remainder is 0, 21. 21 plus 4 is 25. So this is not a multiple of 9, that's what this number is not divisible by 9. No, this number is not divisible by 9. No. But the question is, find the quotient. We need to find the quotient and as well as the remainder, right? Right. Let us check out this. Now 25, so consider, compare with the 9. Actual 9 is the divisor, right? So when you divide, you won't get anything, but what you can get here, 25. So 9 2s are 18. 2 you are going to get quotient, and as well as 7 is the remainder. Correct? 9 2s are 18 plus 7 25. Now to find the actual quotient, now what we need to do, this 2 we need to add to the last digit. So 2 plus 1 is 3. So 6 plus 2, this one we need to add. 6 plus 2 become 8. So 1 plus 0, 1. 1 plus 1 become 2. So and 7. 2183 is going to become your quotient, and 7 is going to be remainder. You can check out by your method only, normal method. 9 6 19 6 5 4. Start dividing by 9. 9 2s are, right, 18. 1 remainder. 9 1s are, 9 1s are 9, that is 7 remainder. 9 8s are 72, 3 remainder. 9 3s are 27, so 7 is the remainder. So the answer is 2183 by 7. 7 is the remainder and 2183 is the quotient. Here what you are supposed to do, if it is 9, directly work with the normal method, and as well as the Nikilam Sutra you can apply easily. You can apply Nikilam Sutra, and to find the quotient and as well as remainder, and as well as for divisibility you can apply, that is Navashesha. Navashesha you can apply to check the divisibility, right? To find the quotient and as well as the remainder, you can go with the Nikilam Navataha Sutra, which you learnt in the second level. Correct? Nikilam Navataha. Okay, but for 19, 29, see, for other number which is ending in 9, so you have to go with this method only, right? For example, if you want for 39, for 29 you are supposed to adopt this. For 19 you are supposed to adopt this, because both the numbers are prime numbers. For 39 you can go with the 13 and 3. First you go test with 3 and then with 13. So for 49 directly go with the 7. For 69 again, for 3 first you check, then go with the 23. So 23 I will show you how to do it. Okay, hope you understood. Let us solve in the next video. I am going to solve by 19. Okay.